Hello and welcome to this tutorial on RDS Analyst. I'm Ian Fellows, and today we're going to talk about sample homophily. So the sample homophily is the degree to which people in the same type of categorical variable tend to recruit people in a similar type. So do people who are HIV positive tend to recruit people who are also HIV positive, more than we would expect by chance. And the first thing that we can do is we can go into sample recruitment homophily. And the data set that I've loaded is the faux data set. So hitting up recruitment homophily, let's go ahead and check our homophily by X, Y, and Z. And we'll run this. And we get a number of different outputs, one for each variable. We've got an X, a Y, and a Z. And what the output for each variable is, first of all, homophily. Now, homophily here is defined in RDS Analyst as the ratio of the rate at which like recruits like more than would be expected by chance. So a recruitment homophily of 1 indicates exactly as much like-to-like recruitment as would be expected by chance. A recruitment homophily of 2 indicates twice as much like-to-like recruitment as would be expected by chance. And we can look specifically here in the table of the value of respondents, so red tending to recruit other reds, or red tending to recruit other blues, and blue tending to recruit blues, or blue tending to recruit reds. Now, also included is a test for independence, but just as a note, this does not take into account the RDS recruitment process. To do that is a little more complex. So I wouldn't report these in, let's say, a journal article, but they're good sort of baselines to understand how much we can be certain that differing from 1 is actually true. And see, here we have Y, a recruitment homophily of 2.3, so 230% more like-to-like recruitment than we would expect by chance, and a p-value here very, very small. So here we see a lot of homophily in Y. And what that can do is that can inflate the amount of variation in our RDS estimators. If there's a very high homophily, it can be very difficult for population frequency estimates to get a good, accurate number on the various levels of black, blue, green, and blue in your data set. And here we have another one with a relatively high homophily as well. And so that's how we take a look at the sample homophily. And then we can also take a look at the population homophily. Now, what this does is it adjusts for the RDS recruitment process, and you give it a population size estimate as well. Now, here what we get is population homophilies broken down by each level, adjusted for the recruitment process. So here we have a homophily of 1.3 for X, again not very big as we had seen before. For Y we see 3 homophilies. The like-to-like for black is 2.4. The like-to-like to blue is 5.7, and the like-to-like for green is 798% more like-to-like recruitments between greens than we would expect by chance. So very high homophilies in here, and it does seem to vary quite a bit between different levels. For Z, the like-to-like recruitment is 5.7, so actually quite a bit higher when we attempt to do a population estimate compared to what we see in the sample after adjusting for the RDS recruitment process. And so this is what we've seen is how to take a look at population homophily in your data set. And this is an important component of understanding what the properties are going to be for your frequency estimates. Because if you have a high homophily, you're likely going to have very high design effects in your frequency estimates, and you're not going to be able to get a really good handle on it.